So let's talk about number sense, which is kind of the first main line. And I should say you're going to see a bunch of screens like the one you're looking at now. And so let me just explain. I don't have a pointer, unfortunately. That green circle that you see in the upper right is just what grade the screenshot is from. Next, you're going to see the mathematical goal of the activity, not what we say to the student, but what the mathematical goal is in kind of more adult mathematical language. Then screenshots of what the student sees, and then that text at the bottom is what the student hears. And I'm going to show you a sequence of activities, both within lessons and across lessons and grades, that are part of this topic. So this is how we introduce the number 4. It's actually how we introduce the numbers 0 through 10 in our pre-K. That's what the second half of our pre-K is introducing those numbers. And so you can see before we ever get to 4, we compare the number of objects in two sets using a one-to-one correspondence. So you can see we ask which is there more of, tomatoes or bugs. If the student gets it wrong, we make them connect a tomato and bug. And then which we have fewer of. So before we've introduced the word 4, the numeral 4, we are comparing the cardinality 4 to the cardinality 3. And now you're, by the way, seeing a sequence of exercises in one lesson. So the next step is to sort of make the equality 3 plus 1 equals 4, but in pictures. You can see, can you make it so there's a bug for each tomato? There are fewer tomatoes, so we need to add. Now there are as many bugs as tomatoes. And so that right-hand screen is a picture of the equality 3 plus 1 equals 4 that we're going to make numerically in what follows. So now you can see that 3 plus 1 equals 4 picture is still there at the bottom of the screen. And we say let's make an equality. So the students drag cards to make 3 plus 1 equals. And that's the bugs, three bugs and 1 bug. And next, we introduce 4 and count. So I believe that's the first time they hear the word 4. So next, we discover the digit 4 just by process of elimination. Find the digit we use to show the number 4. Well, it's the only one they don't know yet. And so, as you can see, we have 4 bugs. We write the number 4 with this digit, 4. So now they've learned that symbol, and we see the equation 3 plus 4 equals 4. So this was the Peano axioms that was referenced earlier. That's just a sort of fancy way of saying that when we introduce 4, we introduce it as 1 more than the number 3. That's what 4 is. It's 1 more than the number 3. And so next we construct an equality 4 equals 4. And you can see once again we have our 2 pictures. So let's count the tomatoes and drag the number. Count the bugs, 1, 2, 3, 4, and drag the number 4. We have 4 tomatoes and 4 bugs. Drag the symbol we used to show that. And so we represent the relationship between 2 sets using the equality 4 equals 4. And you can see the conclusion of this whole sequence. This equality says 4 equals 4. Now we know the number 4 and the digit we used to write. And we have a similar sequence for, well, a nearly identical sequence for every number 3 through 10. There is also a group of lessons about the numbers 1, 0, and 2 in that order, but it's a little bit different. Well, for sort of obvious reasons, you can't do quite the same thing for the numbers 0 and 1. There's also a song for every number. Probably you have seen some of those songs before. They're all pretty amazing. My favorite is the one for the number 8 because it's about the planets. So this is the continuation. It's a new activity actually in the same lesson. And again, we have quite similar exercises for every number. We're just practicing counting in different ways. So find all the groups of 4 and drag them to the box. Put 4 ladybugs in one box and 4 worms in another. Put 4 dragonflies in one box and 4 butterflies in another. Notice that the second and third activity there require counting to 4, but they also require another skill, which is sorting objects by kind. So there's some logical reasoning that we're building in here also. And my, aren't those worms adorable? And this is another sequence. Part of this sequence is showing 3 different representations of a number. So this is, I believe, what's called concrete representational abstract. First, we have pictures of 1 object, 1 vegetable, 2 vegetables, 3 vegetables, 4 vegetables. Then we show 1 dot, 2 dots, 3 dots, 4 dots, and then the numerals 1, 2, 3, 4. So you can see the questions for each group, count the number of vegetables and put the matching dot card below it, drag the digits to show how many dots are in each card. Now all the digits show the number of dots and the number of vegetables. And so now I think we move to a different lesson, but in the same sequence, number composition. So introducing the composition of the number 4 using a concrete model. You can see on the branch of the top of the screen, we have 4 decomposed into 2 plus 2. So here we have number composition using a concrete model. Count the orange birds, count the purple birds, count all the birds. So that's 2, 2, and 4, and we drag the matching dot cards to make the dot card, the representational equation, 2 plus 2 equals 4. And then we go from the representational to abstract, dragging digits to make 2 plus 2 equals 4. And then we conclude by showing that number bound for 4 at the bottom. Say it with me, 2 plus 2 equals 4, and that means that 4 is 2 and 2. So that's the connection between addition and the composition of the number 4. Another tool that we use pretty frequently, and this is from Moreau, is the number house. It's just, as you can see, a house where the roof is the sum and the houses are the addends. So you can see we make it by first having dots, dragging the numbers on top of the dots, and then we get the number houses for 4. And we use that. We use number houses throughout our KN1 to, if students have forgotten addition within 10, we show, or subtraction within 10, we show them in number houses scaffolding. So here we've jumped a grade. Now we're in K, so you can see in the circle in the upper right. So in pre-K, we cover number composition, addition, and subtraction only within 5. So we do counting and numbers up through 10. So early in K, we introduce number composition, I guess, all the way up to 20. And so here you can see that we have a visual representation using those circles for the number composition for 7. Here the student is expected to complete the pattern to show the other 2 ways of decomposing the number 7. At the bottom, what you see at the bottom of the screen are buckets of paint. So the student clicks on a bucket, and then if they click on a token, it will color the token that color. So that's one of our basic controls. So now we represent number composition by building a number house. So you can see the student has all those bricks on the right-hand part of the screen, and they drag to match what's on the left-hand side. So we're again matching the representational model of the tokens with the abstract model of the written numbers. And finally, we drag a roof to complete the number house for 7. And this is kind of a jump forward towards, I guess, the middle of first grade, but it's just an example of how knowledge of composition of the number 7, which you see here, is used later on in the course. So this is, there's kind of a lot going on this slide, but this is how we teach to, is there a question level? This is how we teach addition and subtraction within 20. We teach students to make it 10. So as you can see in the model at the top of the screen, to take 7 away from 15, you take away 5 to get 10, and then take away 2 more. And what that's represented on the bottom half of the screen by using a decomposition of the number 7. So you see there's a number for 7 written there because you take away 5 and then take away 2 more. And this looks like a lot, but if you think about it, this is probably how you do mental addition and subtraction in your head. You probably subtract down to 10 and then cross 10. Which is sort of a revelation to me the first time I saw this, because it's the strategy I use for mental math, but nobody had ever taught it to me, and I'd never even sort of occurred to me to teach it. And in our first grade, we teach crossing 10 to add and subtract within 20 quite carefully.